homework practice sheet that went with the lesson to do with, can you evaluate a limit, not using a graph or tables, but just direct substitution. So for here, even though it says use properties of limits, we're just going to use direct substitution. And if we can't, then we can say it doesn't exist. All right, so plug in -2. Clearly, you can evaluate it. By the way, that's a great answer. If you wanted to further simplify it, that's fine. You could use a calculator or just your brain, and you can get an answer. But I kind of want you to just be comfortable with that's a good answer, that there's no reason to simplify that any further. So I'm going to let it go. Same thing here with number 2. Can you do a direct substitution and understand that a direct substitution gives you an answer, that it is continuous around 2, that there's no asymptote at 2. If there was an asymptote, you'd plug it in, and what would happen to the denominator? The denominator would be 0. So there's no asymptote there. You can definitely do it, and that is the answer. Done. Number 3. Again, direct substitution. So we're going to substitute in 8, and we're going to let it go, and no, it's continuous there. There's no break or jump or asymptote. It's a polynomial. Here again, we just got to be careful that it's a real answer. So when I plug in -5, what happens is this becomes +15. So we don't need this, but that is a real answer. If that answer was imaginary, then the limit would not exist. Let's look at number 7 and on here. So we're going to plug in -16. I need to be careful. When I divide and add 9, is that a real answer? The answer is yes. So we can leave the answer like that because we know that 16 divided by 4, that's -4 plus 9. Clearly a positive answer. The square root of a positive number is real, and the limit exists at that number. Here, when I do that, and by the way, if you did simplify it, I don't know why, my brain just wants to do that, it would be the square root of 5. 8. We need to be careful, especially for a rational. So for a rational, I'm going to separate the numerator and the denominator. So I can see the numerator, the limit is 9. The denominator, when I substitute in, the answer is 0. So anytime this creates an asymptote. So if it's 0 divided by 0, it's indeterminate, and that means there's a hole. And it could or may or not exist. We need to do more work if that's the case, 0 over 0. But in this situation, any number but 0 divided by 0, that's an asymptote, and that means this does not exist. Again, this is a polynomial, so I know that it is continuous, no breaks, jumps, no asymptotes. Oh, make sure everywhere there's next, substitute -5 in, and then let it go, Elsa. Here we go. -3 again. Well, I need to be careful. So the numerator, I'm going to separate it. So there's the limit of the numerator only, because I want to know if that's 0 or a number other than 0. So I can see that's -28, not 0. The denominator, the limit as x approaches -3, that's 2. Oops. I should really write this algebraically, and then the number for the answer. So I'm going to do that here, algebraically. And then what answer do you get when you substitute in? So when I look at the denominator and I plug in -3, you get the answer 0. So that means this does not exist. This is an indicator that there's an asymptote. You also need this. This number not 0, and this is 0, that's an asymptote. Number 11, does this give you a real answer? No. So when you substitute in, you get the square root of -1. I don't even write that down because it's not real, it's not part of the limit, it's not equal to it because it does not exist. So I don't want to get in the habit of going equals the square root of -1 because they do not equal each other. That's mathematically wrong. But because it is the square root of -1, because it is imaginary, that's why it does not exist. But I don't want to write down something that is mathematically incorrect. Equals the square root of -1, they are not equal to each other, so I don't write it down. 12. Oh, and some trigonometry. So pi. First of all, you know what I do when I have that? I draw a little unit circle and picture. Where is pi? That point on the unit circle is -1, 0. The value of cotangent there is x divided by y. And when I go x divided by y, I can see that this limit does not exist. Oh, wait a second, it's pi over 2 when I plug in. So when I plug in, it's actually pi over 2. It's up here. So when I plug in pi, it becomes pi over 2. So it's actually at the top, which is 0, 1, ha. And there, when I go x over y, I actually can get an answer. So x divided by y is 0, and 4 times 0, this whole answer is 0. That's what it's approaching, and equal to. Another trick question. This one is continuous because sine and cosine are continuous, which makes it easy to understand. And I just need to substitute in, and I have an answer. So an understanding and awareness that a function is continuous. And for trigonometry, sine and cosine are the only two continuous functions. I can just plug in, and the limit always exists. For the other 4 trig functions, they have asymptotes. And we need to be aware, is it approaching the asymptote? If it is, then the limit does not exist. Here we go. Substitute in. Now, I don't need much here. I can see clearly that if you plug in 5 in the denominator, it is not 0. So the limit exists. This is continuous there. So you have just a complete substitution here, and then let it go. You could simplify that to 7 over 4, but not necessary. All right, last one here. The limit of 3 times cosecant 2x. So let's make sure I understand. When I plug in pi over 2, what's the angle there when you simplify it? So 2 divided by 2, this is pi. So now we're back here understanding where is pi. So when I substitute in, the 2's divide out, and you're just left with pi, and that on the unit circle is here. That's at -1 and 0. So when I do that and understand it, is cosecant, is it continuous or not continuous there? Well, cosecant's the reciprocal of sine, the y-coordinate. And the reciprocal of 0 creates an asymptote. So there, at pi, it does not exist because there's an asymptote there when you simplify it for the angle that it is. All right, Mr. G Math, over and out. I'm proud of you. You're doing your work. And until next time, thank you.